Boys and girls, are you ready? I hope you are. I am. Pull up some popcorn, pull up your graphing calculator, pull up a chair, and stay a while. So it's been a wild ride. This may possibly be the very last geometry video that I ever make. I think I've pretty much made a video for every single concept, every quiz, test review that I possibly can. So this might be my final farewell to the geometry videos. I think I might just retire after this one and ride off into the sunset. What do you think? Just kidding. I'm going to be around for a long time. So I'm going to skip all the other introductions and let's just jump right in for sake of time. I'm probably going to have to break this video into two parts anyway. Okay, so here we go. Number one, ABC is a dilation of triangle A prime, B prime, C prime is a dilation of triangle ABC by a scale factor of 1/2. The dilation is centered at point 5, 5. Guys, that piece of information really is, we really don't need that. But basically what they're saying is we're kind of starting from this point and the dilation is kind of centered around that point, but we don't need that to answer this question. It says which statement below is true. Okay, so this is going back to our similarity chapter. It doesn't matter which way we go, which direction we go, we just got to follow the same path. If I start from the small triangle and compare that to the, if I start from B prime, C prime and go to BC, then I've got to follow that same pattern. If I'm going from little triangle to big triangle, I've got to go from little triangle to big triangle. If I go from big triangle to little triangle, I've got to go big triangle to little triangle. Okay, so I've got to follow that same path. I'm actually going to go ahead and color code these guys, the two lines in question here. So BC would be in green. That's going to match up with B prime, C prime. And I know it's May. Let's go Christmas colors. BA will of course match up with A prime, B prime. Alright, so let's look and see which one of these is correct. So in option A, they're going from AB, they're going from red, big red, over little red. Okay, that's fine. Big red over little red. That's got to be the same as big green over little green. But what did they do? They went little green over big green. They went big to little, and then they went little to big. Okay, you cannot do that. Alright, that doesn't work. The B, they went from big red to little red, and then they went big green to little green. Is that right? Big red to little red, big green to little green. Yeah, that's right. So there's your correct answer. Let's look at the other two real quick though. C goes from big red to big green. That's fine. I can do that. If I go big red to big green, I got to go little red to little green. But they went little green to little red. Big red to big green, but then little green to big red. Cannot do that. Okay. And D, they went from big red to big green, but then they went AC. I didn't even color that one, so of course that can't be right. All right, number two, in the triangles shown, triangle ABC is a dilation by a factor of 2/3 to form triangle RST. Okay, so we've got this smaller triangle. This guy is 2/3 as big as that guy. Okay. Given that the measure of angle B is 70, so let's go ahead and write that guy in. That guy is 70 degrees. And the measure of angle C is 50 degrees. What is the measure of angle R? Okay, when I dilate, guys, when I make this triangle 2/3 the size, I didn't change the shape, I just changed the size. So these two triangles are similar to each other, okay, and we know from our third angles theorem, and we also know that when two triangles are similar, all the angles have to match. So if this is 50 degrees and that's 70 degrees, then the angles have to be the same. This has got to be 50 and also 70, but they want to know what is the measure of angle R. They want to know this guy. I'll put a little X there. Well, that means we need to find angle A because angle A and angle R will have to match up. And to do that, I'm just going to subtract 50 and 70 from 180. So you just punch that in on your calculator real quick and you get 60. Okay, so if A is 60 degrees, then of course R also has to be 60 degrees. Okay, similar triangles. Okay, we're going to stay right here on the same diagram for number 3. In the triangles shown, triangle ABC is dilated by a factor of 2/3 to form triangle RST. It's the same thing. This time they're saying that given that TR is 6 centimeters, so given that guy is 6 centimeters, what is the length of CA? Okay, guys, please, I am begging you to use common sense on the EOC. Okay, so please, use process of elimination. If you don't know how to do the math, then you can just, use process of elimination, use logic to make your best possible guess. This line has to be longer than that line, right? Okay, because this guy is 2/3 of that guy. So this line has to be what? It's got to be bigger than 6. So go ahead and use your little, when you're taking the EOC on the computer, go ahead and use your little X button and X out answers that you know are not right. Okay, so now we've narrowed it down to either 9 or 7.5. I'll put an X here. We're trying to find that length. Okay. All right. So 6 is equal to 2/3 of CA because we're dilating by a factor of 2/3. So 6 is going to be equal to 2/3 of X, whatever X is. Okay. Now how do I solve for X? You can divide both sides by 2/3. Okay. But when you do that, aren't you essentially multiplying by the reciprocal? Okay. So if you're dividing 6 by 2/3, that's basically the same thing as 6/1 times the reciprocal, 3/2. That's 18/2, which is 9. Okay, so our answer is 9. But let's stop for a second. Let's just use common sense and think. Is 6 2/3 of 9? Yeah, of course it is. Okay, so always use that 5-second gut check. Does my answer make sense? Does it pass the laugh test? Is this a reasonable, believable answer? Okay. All right, number 4 in the triangle shown, AB is parallel to DE. I wonder if it would help if I actually show you guys the problem. Maybe. All right, these two lines are parallel, so let's go ahead and write some arrows there. Lines are parallel. What is the length of CD? Okay, put an X there. That's the variable. Okay, so if you guys remember, you might not, when a line is going through a triangle that's parallel to the base, it splits these sides into lengths that are proportional. This is called the side splitter theorem. I'm going to go ahead and color these guys. Hopefully you can see it on the video. I'll color this guy purple. I will color this guy red. I will color this guy orange. I'll just put the purple and the orange up there together for some crazy reason. I don't know. And then I'll label that guy, or I'll color that guy green. Okay, so if you remember the way I taught you guys, it doesn't matter the path that you take with similarity. You just have to be consistent with your path. There are multiple ways to set up this proportion. I can go from left to right. I can go from purple to orange. I can go purple over orange would have to be equal to what? Red over green. Okay, that's left to right. I can go right to left. Orange over purple has to be the same as green over red. I can do it top to bottom. I can go orange over green will be the same as purple over red. I can go bottom to top. Red over purple equals green over orange. The only way you guys can mess this up is when you cross the streams in Ghostbusters. Don't do that. Don't cross the streams. I can't do purple over green equals orange over red. Okay. So how do you guys want to do this? You're the boss. That's why I love math. You can control what do you want to do. I'm going to go left to right to stick with my Clemson colors. I'm going to go purple over orange. X over 5. That's got to be equal to, if I went left to right, that's got to be equal to red over green, 3/2. I'm going to cross multiply. 2x is equal to 3 times 5, 15. I'm going to divide by 2, and we get x is equal to 7.5, which is D. Okay, watch this. I'm going to switch. I'm going to go bottom to top. I'm going to go green over orange, 2 over 5. If I go bottom to top, I got to go bottom to top. Red over purple. Red over purple. When I cross multiply, I get 2x is equal to 15. Oh, looky look. We get the exact same answer. Okay. So there's multiple ways as long as you're consistent with your pattern. Okay, number 5. Lovely proofs. You know there are going to be some proofs on there, boys and girls. You know it. I know this is your favorite stuff. In the triangle shown, HJ is parallel to GK. That's what they're showing here with the arrows. The following shows a proof of the statement: if a line is parallel to one side of a triangle and intersects the other two sides at distinct points, then it separates these sides into segments of proportional lengths. That's literally exactly what we just did. This line separates these lengths, separates this side into lengths that are proportional to each other. Okay. Which reason justifies step number 2? The first step in my proof, guys, is always the given, which they have. And then the second step, they're saying angle HGK. Okay, put your pencil on it. HGK, got it. Okay. That angle is congruent to angle IHJ. Okay, got it. Those two angles are congruent. Why? Okay. Well, look at your answers. We got alternate interior, alternate exterior, corresponding vertical angles. This takes us back to chapter 2 stuff with parallel lines. And I know you can't write on the computer, you can't write on the computer screen, but you guys are going to have as much scratch paper as you need. Okay, so I'm a big believer of drawing this stuff out. So draw these lines out on a separate piece of scratch paper. There are our two parallel lines. Okay, so here comes the alternate interior angles, all that good stuff. This angle is inside the sandwich, but this angle is outside the sandwich. So they can't be alternate interior because they're not both inside the sandwich. They can't be alternate exterior because this guy's inside, but this guy's outside. So then it's just a matter of corresponding angles or vertical. They're obviously not vertical angles because vertical angles are angles that form an X. They're on the opposite sides of the X. So by process of elimination, they're corresponding angles. But if you remember the way that I taught you, corresponding angles are in the same position in the window. So this angle is up in the top right of the window. This angle is also in the top right of the window. And when they're in the same spot in the box or the window, those are corresponding angles. Okay, number 6, consider the triangles shown, which can be used to prove the triangles are congruent. So this is our triangle congruence postulates. Okay, so this is pretty easy. I've got a side, I've got tick, double arcs, double ticks. So notice where the arc is. It is sandwiched in between the ticks. So this is S, A, S. Over here on the other triangle, I also have S, A, S. Okay, so that's SAS, side, angle, side. So these two triangles are definitely congruent by SAS. If this arc, or say this tick had been over here, you would have angle, side, side, and that's not one of them. Okay. If I didn't have this tick and I had an arc here, that would be ASA, angle, side, angle. Okay. Number 7 says, consider the triangles shown, which would be a correct congruent statement. Okay, so once again, a lot of this stuff with triangles, similarity, it's all about the path that you take. You just got to be consistent. Okay. All right, so how are we going to figure out a path for these guys? Well, what I would do is, since I already know that these two triangles are congruent by SAS, I'm going to go ahead and put myself, this is me personally, Mr. Manise, I'm going to go ahead and put triple ticks on the other side. Okay, that's just going to help me get oriented so I make sure whatever path I choose when I name the triangle, I'm going single tick, triple tick, double tick, and then single tick, triple tick, double tick. I just got to follow the same path. So let's take a look at these answer choices. A, B, C. Okay, A, B, C. They're going triple, double, single. Okay, so over here I would have to go triple, double, single. That would have to be E, D, F. That's not what they have. They have D, E, F. Okay, so that doesn't work. B, C, A. Okay, B, C, A. Double, single, triple. So over here, I got to go double, single, triple. D, F, E. That's not what they have. That was not right. Okay, B, A, C. B, A, C. Triple through the single. So I'd have to go triple through the single. D, E, F. That's not what they have. They had D, F, E. So of course by default the answer is D, but let's just double check just to make sure. C, A, B. C, A, B. They're going single, triple, double. F, E, D. Single, triple, double. Yep, there you go. That's the one that works. Okay, number 8. Which information would provide enough information to prove that triangle ABC is congruent, not similar, congruent to triangle DEC? Okay, AC is congruent to DC. Okay, so they already have the ticks there for us. That's fine. What other information do I need to prove that the triangles are congruent? Okay, well remember, we've got several different ways to prove congruency. SAS, SSS, ASA, AAS. Technically, we have a fourth one, the hypotenuse leg, HL, but that only works with a right angle, which we don't necessarily have in this problem. Okay, so I'm looking for one of these combinations. Okay, so I'm always looking to ask myself, where can I add ticks and arcs to my diagram and all these triangle congruence postulates and proofs and stuff? Where can I add stuff? They've already given me one set of ticks. I need 3 sets. I need 3 sets of arcs, 3 sets of ticks, some kind of combination. Well, you notice these are vertical angles. Okay, so go ahead and add your arcs right there. All right, so now I have 2 sets. I got a set of ticks and a set of arcs. So I have an S and an A. I'm still looking for another combination here. Let's look at our answer choices. ED is congruent to BA. ED is congruent to BA. Okay? I'm not going to write this in pen because actually I will grab this pencil here so I can erase it. If we say ED single tick is congruent to BA single tick, does that help me? I have tick, double tick, arc. I have side, side, angle. I have angle, side, side. Angle, side, side. That's not one of them. If it spells a bad word, boys and girls, frontwards or backwards, it is not one of them. Okay? SSA, ASS, that does not work. Thank goodness for erasers. Okay. See you later. Get out of here. Next one. AD is congruent to EB. AD is congruent to EB. That doesn't really help us because I already know that AC and CD are the same. If you tell me this whole length is congruent to this whole length, that doesn't necessarily mean anything about these two lengths. Okay, these two guys could be the same length, but this could be a lot shorter than this one. Okay, I could have a single tick here and a triple tick here, but these two lengths still be the same. Okay, so that doesn't really help me. Okay, what about the third one? ED is parallel to BA. I'm going to go ahead and tell you that's the correct answer. ED is parallel to BA. Okay, when two lines are parallel, guys, remember to look for the Z. Look for the Z the way I taught you. Here's the Z. Okay, there's the Z. Okay, I'm literally forming the letter Z. So it can be backwards as well, but I'm literally forming the letter Z. The crux of the Z, guys, the little crevice of the Z, those two angles will always be the same because of alternate interior angles. If you were to extend this out, okay, these two angles are both inside the sandwich. They're on opposite sides or alternate sides of the transversal. You remember all this stuff from chapter 2, two parallel lines cut by a transversal. So that allows me to put arcs, and actually, you know what? I need to put double arcs here because we've already used the single arcs there. So these two alternate interior angles will be the same. And now look, guys, I've got angle, side, angle, angle, side, angle. So I get to use ASA. Okay, so the correct answer is C. That allows me to put those arcs there. D is not right because if you tell me AD, if you tell me this line is perpendicular to EB, if you tell me these are right angles, that doesn't help me because I already know that these two angles are the same. So if you tell me that these are both 90 degrees, okay, fine. I already knew they're the same because they're vertical angles. So that doesn't help me. Okay, one page down and about 49,000 to go. Okay, number 9. In the diagram, triangle STU is an isosceles triangle where ST is congruent to UT. The paragraph proof shows that angle S is congruent to angle U. And they're asking which step is missing in the proof. Okay, it is given that ST is congruent to UT. Okay, got it. Tick, tick. Draw TV. The explanation is draw a line such that it bisects angle T. Okay, I'll put arcs right there at angle T. By definition of an angle bisector, angle STV is congruent to angle UTV, which is what I just showed. Arc there, okay? By the reflexive property of congruence, TV is congruent to itself. Remember, ticks in the middle, ticks in the middle, ticks. Y'all remember the little drum beat? Ticks in the middle, ticks in the middle. Okay, sorry. All right, so triangle STV is congruent to triangle UTV by SAS. Side, angle, side, side, angle, side. Okay, all that's correct. Therefore, angle S, this guy, is congruent to angle U. Why is that? Okay, so the way I taught you guys in class with this whole CPCTC thing, this is the correct answer, but if I were to tell you guys that two students are identical twins, okay, then you can tell me a lot about those two people, those two girls or those two boys, okay? They probably have the same hair color, they probably have the same eyes, the same facial features, you know, they look the same height, all that kind of stuff. So if you tell me that they're both twins, what can you tell me about their facial features? I can say, well, their facial features are probably the same. What can you tell me about the hair color? They both have the same hair color, okay? We just proved that these two triangles are identical twins. That's what we just did. These two triangles are congruent by SAS. So what can you say about their hair color? They both have the same hair color. What can you say about these two angles? They both have the same angles. What can you say about these two angles? These two angles will be the same. Everything about them is the same, guys, because they're identical twins. And that's because of CPCTC. Corresponding parts of congruent triangles are congruent. If you see a proof on the EOC, guys, about triangles, the last step in the proof will always be either one of these triangle postulates, SAS, SSS, ASA, whatever, or it's going to be CPCTC. If you've already used the SSS to prove they're congruent, they ask you to go one step further, it's always going to be CPCTC every single time. Okay, so just remember that. Okay, number 10, consider the construction of the angle bisector shown, which could have been the first step in creating this construction. You're not going to be using compasses on the EOC because it's on the computer. So this is how they get around that. They're going to ask you this type of question. What would be the first step in creating the angle bisector? So if you guys remember from our constructions unit, the first thing we did is we put the compass on that point. We came up here, we opened up the compass, we swung an arc out here, and then we put our compass on that spot, swung an arc out here, then switched our compass over to this spot, swung another arc out here, and where they intersect, we drew a line. Okay, so what's the first step in this construction? The first thing that they did was they put their compass on point Y, and they swung an arc to make points A and B. Okay, so what's the correct answer? Place the compass on point A and draw. No, I don't want to put my compass on point A. I need to put my compass on point Y. That's not right. Place the compass on point. Nah. I got to put my compass on point Y, the vertex, and draw an arc that intersects YX and YZ. That's what I want, guys. I want to put my compass right here, put my compass right there, and I want to swing an arc that crosses these two lines. Okay. So the correct answer is C. Put the compass on vertex Y and draw an arc that intersects point C. No, we're not ready to do that yet. I need to swing this arc first. So the correct answer is C. Okay. Use the line segment HI to answer the question, which step should be the first to draw a line perpendicular to HI at midpoint J? Okay. I want to draw... I'm basically drawing a perpendicular bisector, right? Because point J is the midpoint. Okay, so hopefully you guys remember this one. If they're going to ask you about constructions, I can almost promise you it's probably going to be about a perpendicular bisector. So this is the one where we said we're going to put our compass on point H, and how far are we going to open up the compass, guys, for perpendicular bisector? We're going to open it up about 75% of the way, about 3/4 of the way. And I'm going to come out here, swing a big arc out here, and then what? I'm going to switch my compass over to this point, and I'm going to swing another big arc out here. And wherever the two arcs intersect, I'm going to connect that line, and that will be my perpendicular bisector. But I'm opening up my compass to about 75% of the way. Well, they don't have 75% of the way. That's just a Mr. Manise thing. So the first thing I want to do is I want to put my compass on point H and set its width to more than HJ. Okay, I used 3/4 of the way, but it just needs to be more than 50%. So that's the correct answer. Okay, I don't want to put I'm never going to put my compass on point J. I've got to start either here or here and then go for 75% of the way. So that's why those two are wrong. Okay, number 12, trigonometry. Now, as you guys are working through this EOC mock test, remember, this formula sheet, guys, is on my website. If you go to markmanise.com, go to Resources, EOC Review, then I have a link here to this formula sheet. So you'll have all this at your disposal on the EOC test day. So you guys just not maybe, I went over this in class to refresh your memory, but you might want to just pull up this file again as you're working through so you have all these formulas as you're working through the problems. Okay, so this is all trigonometry. So pop this up. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. There's our SOHCAHTOA. Some old hippie caught another hippie tripping on. Yeah, I'll let you fill in the blank there. Okay, so what is the value of the cosine of A? So cosine is defined as adjacent over hypotenuse. Okay, the way I taught you guys to do this way back in the trigonometry chapter is the first thing I want you guys to do is circle your angle. Okay, circle it so your brain focuses on that letter, so you don't get mixed up with the other B and the C. I'm just looking at that letter, that angle. The second thing I told you guys to do was to label your sides. Always start with the hypotenuse. 15 is your hypotenuse because that's the longest side opposite the right angle. The opposite, which one's opposite? Well, opposite. Which one's further away, the 9 or 12? Which one number is literally further away? 12. Okay, so there's your opposite, is farther away. And the 9 is closest to A, so there's your adjacent. Okay, so in this case, they don't want us to solve anything. They just want to write what is the fraction, what is the cosine of A. And it's going to be adjacent over hypotenuse. That's 9 over 15. Notice that's none of your answers. That's because we didn't simplify this. Divide the top and bottom by 3, and we get 3/5. Okay, cosine of A. Okay, flip on over. All right, so there's a large tree 80 feet from a house. The owners are worried that the tree might hit their house if it fell and want to estimate the height of the tree. If you guys remember this, I literally told you that I did this in my backyard. Okay, this is the day that we got out the mirror on the ground. Remember that? We estimated the height of the door in the classroom. I told you I used this in my backyard to estimate the height of a tree to see if a big storm came that it wouldn't fall and hit my house. So this is literally the exact same problem. It's kind of funny. All right, so in the figure below, when the sun's angle of elevation is 50 degrees, the tree casts a shadow 80 feet long, which can be used to find the height of the tree. Okay, what did we just say? What's the first step? Circle your angle. Second step is what? Label. I don't have anything for the hypotenuse, so I don't need to label that. The x is on the opposite side. The x is farther away than 80. So x is my opposite, and then 80 is my adjacent. Adjacent. Okay. So look back at your formula sheet, and which one has opposite and adjacent in it? Okay, opposite and adjacent, that's your tangent. Tangent is defined as opposite over adjacent. Okay, so I would need to use this one. The tangent of 50 degrees is equal to opposite over adjacent. Okay, this is the correct answer. I want to go through this real quick and actually solve this. If you guys remember, in case they actually ask you to do this on the EOC, to solve this, guys, if you remember the way I taught you, when the variable is on top, what do you do with these two things? You multiply them. So on your calculator, you're literally going to, oh, and by the way, guys, when they reset your calculator, a reset calculator is going to default to radian mode. Okay, so don't forget that. If you're using trigonometry with your calculator, don't forget to press mode and scroll down here and go over and make sure that degree is highlighted. I'm pretty sure that reset calculators default back to radian, so please, please make sure that you don't fall into that trap, that you're in radian mode. When the variable's on top, you multiply these two guys. So I'm just going to multiply tangent of 50 times 80, and I get 95. Okay, would that make sense for a 50-degree angle? If this is 80 feet, would you buy that the tree is 95 feet? Yeah, I'd buy that. Okay, what if you had gotten these mixed up? What, instead of multiplying, you divided? What if you did 80 divided by the tangent of 50? Okay, 67. Okay, if this angle is more than 45 degrees, okay, would it make sense that this opposite side is shorter than that side? No, because this angle is large. The angle is opening up. So this opposite side has got to be larger than 80 feet. Okay, so if they were to ask you to solve this, use some common sense there to make sure that you're setting up and solving your equation correctly. Okay, number 14 is, in my opinion, is the hardest one in the whole packet. In right triangle HJK, angle J is a right angle and tangent of H is 1. Which statement about triangle HJK must be true? Guys, unless you are a math genius, it is impossible to figure this out unless you draw a picture. When you get stuck, especially with geometry shapes, forget about quadratics and algebra, forget about polynomials and combining like terms. True geometry with shapes, draw a picture, please. I'm begging you. So I'm going to draw myself a right triangle. Trigonometry, Pythagorean theorem only works, it's only applicable to right triangles. Okay, they tell me it's right triangle HJK, and they tell me that J is the right angle. So it doesn't really matter where the H and the K goes. I'll just follow HJK. Now they're telling me that the tangent of H is 1. Okay, so if I go back and look at my formula sheet, opposite over adjacent. Okay, tangent of H, circle it. Okay, opposite over adjacent, they're telling me has a value of 1. This guy over this guy equals 1. So what does that mean has to be true about these two lengths? The only way to divide this guy by this guy and get 1 is if these two lengths are the same, right? We don't know what these lengths are. Maybe it's 21 and 21. Maybe it's a million and a million. Maybe it's smiley face and smiley face. We don't really know. I'm just going to put in a number. I'm going to put in 1. I'm going to say that side is 1. I'm going to say that side is 1. Okay? All right, so now we got to figure out the rest of these, figure out which one of these is correct. However, before I do that, I really would like to figure out what is the length of this third side. And if you guys remember our special right triangles, if you have a isosceles triangle, which these are because the two lengths are the same, when you have an isosceles right triangle, if you guys remember, these two angles are 45 degrees. Okay, and if you remember, if that's x and that's x, what is the hypotenuse? It is x times the square root of 2, one of our special triangles. Our other special right triangle was the 30, 60, 90. And if the short side is x, then the hypotenuse is 2x, and the long side is x root 3. Just in case y'all see that on the EOC. Those are our special right triangles. So if this is 1 and this is 1, that's like x and x, what would the hypotenuse be? X root 2, 1, 1, 1 root 2. I don't really need to write the 1, but I'll write it there anyway. Okay, so now I got some numbers that I just threw in there. Okay, this might not be right. That might be. This could be 14, 14, 14 root 2. But I just need something in there so I can solve this problem. Okay, let's check this out. Sine of h is opposite over hypotenuse. Opposite over hypotenuse is 1 over 1 is 1 divided by square root of 2. Is that 1/2? No, it's not 1/2. Is 14 over 14 root 2. 1/2. It doesn't matter what these numbers are. The ratio, it doesn't work out. Sine of h, opposite over hypotenuse, is that 1? No, of course not. 1 over square root of 2 is not 1. These two numbers will not be the same. The opposite and adjacent are both the same, but the opposite and the hypotenuse will not be the same. So that can't be right. Sine of h, opposite over hypotenuse, is 1 over root 2. Cosine of h, cosine is adjacent over hypotenuse. That is also 1 over the square root of 2. And therefore, that is your correct answer. And again, I can't overemphasize this enough, guys. It doesn't matter. You could have picked any numbers that you wanted to put into this triangle. And all of these ratios would have still worked out. Okay. So in this case, C is your final answer. That's a tough one, guys. I'm not gonna gloss over that. That's a tough one. All right, in right triangle ABC, A and B are complementary angles. The value of the cosine of A is 5/13. So what is the value of the sine of B? What are you going to do, boys and girls? Draw a picture. Trigonometry. That's a right triangle. Okay, A and B are complementary. What does that word mean? Complementary. Okay, what does supplementary mean? Supplementary means they add up to 180, right? So what do you think complementary means? It adds up to 90. Okay, so that means C has to be my right angle and A and B are my two complementary angles. How do you remember that? If somebody gives you a compliment, then if somebody says, hey, you look nice today, then you can say, you right. You right. Get it? Get it? Complementary angles add up to 90 degrees. You right? Somebody gives you a compliment? Okay. All right, so the value of the cosine of A. All right, circle A. And let's label. This would be my adjacent. I'm just going to label it with capital letters. Adjacent, opposite, hypotenuse. The cosine of A is 5/13. So the adjacent over hypotenuse is 5/13. Okay. So therefore, what is the value of the sine of B? All right, so now when I look at B, the sine is defined as opposite over hypotenuse. Guess what? Opposite over hypotenuse is also 5/13. Okay, if you see this on the test, guys, you can remember the little shortcut. The cosine of an angle is always the same as the sine of the other angle. Cosine of A always equals the sine of B, or the sine of A equals the cosine of B. Okay, every single time. All right, 16. We are in circles land. All right, in the circle shown, BC is the diameter, and the measure of arc AB is 120 degrees. Guys, when you see this diameter going through the circle, that ought to be a red flag, just like I taught you in the circles unit. Hey, ding, 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 maybe I need to use a semicircle here, half of a circle. Okay, this arc is 120 degrees. So how would I figure out what the green arc is? Green arc. Joker colors. You got any Batman fans out here? If this guy is 120 degrees, the whole thing, arc BAC, is a semicircle, right? And that's going to be 180 degrees because that's half of a circle. Okay, this whole thing is 180 degrees. So if that's 120, what does that guy have to be? 180 minus 120, that guy has to be 60 degrees. Okay, this is another problem where they're kind of combining two standards into one. All right, so now what is this angle called, guys? If you can't remember, now one reason that chapter 8, the circles unit, was so hard is because you had to remember all that stuff. You had to remember what's an interior angle, what's an exterior angle, what's an inscribed angle. So I would suggest you guys get out your notes from the circles unit and go back and look through the student guided notes and refresh your memory on what you do with all those formulas. With an interior angle, you add them and take the average. Exterior angle is 1/2 big minus little, all that good stuff. Okay, this is an inscribed angle because the vertex is on the circle. The relationship between the inscribed angle and the arc is the inscribed angle is half of the arc. So this guy has to be 30 degrees. Okay. Don't get confused with 60. If it were a central angle, the vertex in the center, if this arc were 60 degrees, then yes, the central angle would be 60. But the vertex is way over here. Okay, then it's half of that, 30 degrees. Okay. All right. Circle P is dilated to form circle P prime. Which statement is always true? Which statement is always true? Okay, so I have circle. It says it's dilated. It doesn't say if it's getting bigger or smaller. Let's, for sake of room, let's just say it gets smaller. P prime. Which of these guys is always true? The radius of circle P, the radius is equal to the circle radius of C prime. No, of course not. The radii will be different lengths. The length of any chord in circle P is greater than the length of any chord in P prime. That's not true. I could have a little bitty chord, just a little bitty baby chord in the big circle, and I could have a big chord in the small circle. And this chord is bigger than that one. See you later. The diameter of circle P, the diameter of this guy, is greater than the diameter of circle P prime. And you might say, well, yeah, that's true. But however, remember, we don't know which way this guy was dilated. This could be P, and P prime could have been a huge circle. So in that case, P prime's diameter would be larger. Okay, so we don't know if it's getting smaller or larger. So obviously, by default, the correct answer is D, but check this out. The ratio of the diameter to the circumference is the same for both circles. If you look at your formula sheet here, circumference is defined as pi d. Okay, circumference equals pi d. The ratio of the diameter to the circumference. Okay, I want to get the ratio of the diameter to the circumference. Okay, so if circumference equals pi d, okay, and if I rearrange this, then I'm going to have pi is equal to the ratio of the diameter to the circumference. Okay, so in other words, pi is defined as the number of times that you can wrap. If I were to take a piece of string for the length of my circle, for the diameter, I could wrap that diameter around the circle 3.141592654, etc., times. Okay, it's the number of times the diameter will wrap around the circle, or the circumference. So that's always going to be the same no matter how big or small the circle is. That's why pi is such a unique mathematical symbol and number, okay, because it's the same for every circle. Okay, number 18, circle with center P has tangents of x, y, and z, x, y, and zy, okay, x, z, and zy. Chords wx and yz are shown in the figure. The measure of angle zwx is 70, okay, got that. What is the measure in degrees of angle xyz? Okay, I want this guy right here. I want this angle. See, I can see that. Okay. So again, this is the circle stuff. Where's that vertex? It's outside the circle. That's an exterior angle. Okay. Then the relationship between the exterior angle is 1/2 of the big arc minus the little arc. So let's do this in colors. Here's the big arc. This is the big arc here in green. And then I got the little arc, the one closest to it, this guy in red. So the relationship is this 1/2 of green minus red. Okay, well, I don't have the green arc, I don't have the red arc. So we're going to have to use some stuff that we've already learned. Here's my snow cone. Follow the snow cone for an inscribed angle. Okay, I forgot to mention that back up here. Inscribed angle has the snow cone. There's the top of my snow cone. Here's the body of the snow cone. There's your angle there. So follow the snow cone. I got a red snow cone. This angle is an inscribed angle. That's 70. So remember, the angle is half of the arc. So if the angle is 70, the arc has to be twice that much, which is 140 degrees. Okay, everybody follow that? Half of 140 is 70. Okay, so that gives me the red arc, but I still need the green arc. Well, remember, we have an entire circle. The whole circle is 360 degrees. So isn't the green arc just the circle minus 140? Well, yes, it is, Mr. Manice. So if I subtract those, that gives me 220 degrees for the green arc. So this guy is 220. Okay, now I'm ready to set up my equation. My exterior angle, x, is equal to 1/2 of big minus little. Okay, that's going to be equal to 1/2 the big green arc, 220, minus the little arc, which is the 140. Okay, don't get confused with the 70. That's an angle. Okay, these are arcs. Big arc minus little arc. Green arc minus red arc. Okay, type that in your calculator, and that comes out to be 40 degrees. Final answer is C. Okay, let's keep going. 2 pages down. We're making a dent. We're making a dent. Okay, circle with center E is shown. The measure of angle CED is 145 degrees. And the length, guys, that's the most important word in the whole problem. You've got to find these important trigger words. The length of CE is 12 centimeters. What is the length of CD? Okay, length. This is arc length, guys. This is area of a sector and arc length. This is the last thing we did in the circles unit. So if I pull up your formula sheet on the test on Tuesday, I don't want area of a sector. I don't want area. I want length. I want arc length. There it is right there. 2 pi r, which is the circumference of the circle, times theta over 360. We taught you guys n over 360. It doesn't matter what that variable is. X, y, theta, n, doesn't matter. It's just a variable. Okay, so our formula is theta. I'll use theta this time. Theta over 360. That's just the percentage of the circle that we're talking about, guys. If this number were 90 degrees, 90 over 360, we're talking about 1/4 of the circle. If that number were 180 degrees, we're talking about a semicircle. We're talking about half the circle. So we're going to take this percentage, a 4, 25% of the circle, 37% of the circle, half the circle, and we're going to multiply that times 2 pi r, which is the circumference of the whole circle. So I think about this as a Papa John's pizza. I want to find the physical length of the crust of this Papa John's pizza. So doesn't it make sense that I would take this percentage of the pizza, this little percentage, that percentage times the circumference of the whole pizza? Okay. But now notice, guys, that you have pi in your final answer. Okay. I hope they don't do this to you guys, but they might. If you see pi in your final answer, do not type in pi into your calculator because pi is in your answer. So when I go to type this in, my theta is my central angle. So this is going to be 145 degrees over 360 degrees times 2 pi times my radius, which is 12. Okay, that's going to give you the arc length. However, I don't type in pi because it's in my answer. So on my calculator, I'll type this in. Make sure y'all can see it. 145 divided by 360 times 2 times 12. I get that lovely number. Cool. Guess what? That doesn't match anything in my answer choices. Remember, you can convert a decimal to a fraction by pressing the math button. Math. And then fraction. I'm going to press enter twice. 1, 2. And it converts it to a fraction for me. There we go. 29 over 3 pi centimeters. Okay, pi is in my final answer. Okay, number 20 is similar. It's the same kinds of concepts here. However, what's the most important word in that question? Area. I don't want the crust of the Papa John's pizza. I want the area of the shaded Papa John's pizza. This is another very important phrase right there. Shaded. I want the shaded part. Okay, so let's pull up our formula sheet here. Area of a sector is pi r squared times theta over 360. So it's the same thing as this. It's the same thing as the problem before. It's just the percentage of the pizza, percentage of the circle that I'm talking about. But now instead of multiplying times the whole circumference, I'm going to multiply times the whole area of my circle, which is pi r squared. Okay, but remember, it's the shaded. I need to find the measure of that angle. Okay, how do I do that? It's simply going to be 360 minus this central angle, minus 75. Okay, that gives me 285 degrees. That is the measure of this shaded central angle. Okay, so don't miss that kind of stuff on the test. All right, so when I plug it in, I'm going to have my central angle, the shaded angle, 285 divided by 360 times pi r squared. Okay, pi times, what's my radius? My radius is 9, times 9 squared. However, once again, guys, your answers are in terms of pi, so do not type that into your calculator. Let's go 285 divided by 360 times 9 squared. Once again, I get a fraction. Okay, let's convert it to a, excuse me, I get a decimal. Let's convert it to a fraction. Math, enter, enter. There you go, 513 over 8. Now, there you go, there it is. 513 over 8 pi. Now notice this is centimeters squared because we're talking about area. This is centimeters because I'm talking about a physical length, one dimension. All right, so number 21. The spokes of a bicycle wheel form 10 congruent central angles. The diameter of the circle formed by the outer edge of the wheel is 18 inches. What is the length to the nearest tenth of an inch of the outer edge of the wheel between two consecutive spokes? Okay, ooh, that's a lot. All right, what's the most important word? Length. So once again, this is arc length. Okay, this is still that same equation. Theta, the central angle over 360 times 2 pi r. Now notice this time, guys, I don't have pi in your final answer, so this time I will type in pi. Okay, I have my radius, the diameter. Please don't make this mistake, guys. Please read these things 2 or 3 times. My diameter is 18, which means my radius is half of that, 9. Okay, 2 pi r, so 2 pi 9. But what is my theta, guys? What is my central angle? They didn't give that to me. All they told me is that I have 10 congruent angles. All 10 of these guys are all the same. Well, if a whole circle is 360 and I have 10 equal parts, can I just divide 360 by 10? Yes, you can, Mr. Manise. That gives me 36 degrees. Come on, camera. Come on, camera. There you go. So each of these guys is 36 degrees. So there's my central angle. Okay, so that's my theta. So 36 degrees over 360, that's 10% because we have 10 equal parts, times 2 pi times my radius, which is 9. And we plug and chug, as we used to say in college. 36 divided by 360 times 2 pi times 9. 5.7. That one. All right, I like it when my answer matches one of the answer choices. Okay, number 22. What is the volume of a cylinder with a radius of 3 inches and a height of 9.5? Okay, so my radius is 3 inches, height is 9.5 or 4.5 inches. And so you're going to pull up your volume formula sheet, press a little button on the computer, pull up the volume formula sheet. Cylinder is pi r squared h. Okay, it's just the area of the base times the height. All right, pi r squared h. All right, my height is 4.5 and my radius is 3. There's nothing really here to do here. However, look again, guys. All of your answers are in terms of pi, so you don't type that in. So I'm just going to type in my radius squared. That's 3 squared times my height, which is 4.5. Type that in. 3 squared times 4.5, and I get 40.5. Okay, that's not an answer choice because they're in fractions. Math. Enter, enter. 81 over 2. 81 over 2 pi. Guys, remember, please remember, as you're going through this video, if I'm going too fast or you're like, man, I still didn't understand that, just rewind it. Rewind the video as many, press the little back button, 10 seconds, 10 seconds. Watch it as many times as you need, okay? All right, keep moving. 23, my goodness gracious. 23 is a toughie. It is a toughie. All right, the cone shown has a base with a radius of AB. The length of AB is 6, so the radius of my cone is 6. The length of BC is 10. What's the volume of the cone? Okay, the volume of a cone is 1/3 pi r squared h. It's basically 1/3 of a cylinder. That's a cylinder, pi r squared h. The cone is 1/3 of that. However, I have the radius, but I don't have the height, guys. This is not the height. 10 is the slant height. And as I hear a collective gasp from the crowd, oh, Mr. Manise, the slant height. I know. Geometry's hard, guys. Math is hard. Draw yourself a right triangle. The slant height is my hypotenuse, 10. The radius is 6. I need to find the height. This is the height that I want here in green. I need this height from the middle of the cone, from the middle of the base up to the top. Okay, so we're going to use Pythagorean theorem to solve this. If you guys recognize that this is a Pythagorean triple, this is just a 3, 4, 5 triangle times 2. There's your 5, there's your 3, so what would that have to be? That would have to be 4, okay? Okay, if you don't remember that, that's fine. We use Pythagorean theorem. H squared plus A squared plus B squared equals C squared. H squared plus 36 equals 100. Move the 36 to the other side. Subtract. That's going to be 64. Take the square root. And H is going to be equal to 8. Okay, so there's my 3, 4, 5 triangle just doubled. So that's going to be, actually this is 4, 3. So that's going to be 6, 8, 10. It's just a multiple of the 3, 4, 5 right triangle. So my height is now 8. Now I'm ready to go. Now I'm ready to plug and chug into the equation. Volume equals 1/3. Notice your answer's in pi, so don't type that in. Times my radius squared. My radius is 6. 6 squared times my height, which is 8. Okay. 1 divided by 3 times 6 squared times 8 gives me 96. There we go. Love it when my answer's down there. Okay, 24. I'll be surprised if you guys don't see this some kind of question on this similar lines with Cavalieri's principle. It's saying two different cylinders are shown. Both cylinders have the same height and they have the same radius, which means their bases are the same. The area of their bases is the same. Okay, so when you find the volume of a cylinder, which is pi r squared h, they both have the same pi r squared area base, and then they're telling me that they have the same height. The only difference is this guy has a 60-degree angle, it's slanted. But if they both have the same base, they both have the same pi r squared, and they both have the same height, what can I say about their volume? Their volume is the same. And the reason for that, guys, is because of Cavalieri's principle. Cavalieri's principle. And what that says, you might see that word on the exam. What that says is if I have a deck of cards here, this deck of cards has a certain volume. This is a shoebox, right? This is a box. Length times width times height. Each of these cards has some kind of cross-sectional area, right? So if I take this box of cards, if I start to slant these cards, so look at it this way, maybe this is a better way to do it. There's my cards. If I slant these guys, if it's slanted, does the volume change? No, I still got the same amount of cards here because the base, the cross-sectional area, all these little bases are all the same, and I still have the same height. So it doesn't matter whether the figure is slanted or not. Cavalier's principle says the volumes are the same. Okay. All right. Number 25. We just did this, guys. We just did it. Radicals. I'll be willing to bet this is probably going to be on the non-calculator part, even though I've showed you how to check your answers on your calculator. So, which expression is equivalent? All right, I'm going to rewrite this a little bit bigger. Perfect land and non-perfect land. Okay, what are our perfect squares? 1, 4, 9, 16, 25, 36, etc., etc. I'm looking for the highest perfect squares that go into these numbers, guys. Can 27 be broken down? You betcha. 9 goes into it, so I can break this down into perfect land and non-perfect land. 9 is a perfect square that goes in perfect land. What goes in non-perfect land of the trash can? 3. 27 divided by 9 is 3. That's perfect. That's not perfect. Can I break down the square root of 12? You betcha. 4 goes into it. That breaks down into 4 and 3. The square root of 9 is 3. And then I just bring down the trash can. I can't do anything with that. The square root of 4 is 2 times the square root of 3. And what's the sign in between these guys? Minus. Subtracting that. I can simplify that. I got 3 apples minus 1 apple. Imagine that these radicals are like variables. This would be like 3x minus 2x. That's just 1x, right? 3 of these things minus 2 of these things equals 1 of these 3 things. 3 apples minus 2 apples is 1 apple. Okay, if this is on the calculator part, guys, use a little trick that I taught you. Plug in the original question, square root of 27, get out from underneath, minus the square root of 12, get a number. Guys, I don't care what that number is. I do not care. I just need a number. Okay, let's type in what we think that simplifies to. We think that simplifies to the square root of 3. Oh my goodness, they match. Confetti falls from the sky, and you move on to the next question. This is a killer, guys. It's a killer cool trick. Please use it. Okay, rational, irrational. We just talked about this. So remember, a rational number is a whole number, a fraction, or a repeating decimal. Okay, that's a rational number. An irrational number is a decimal that goes on forever. So that would be like pi, 3.141592654, etc., 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 etc. Okay, so they're asking which of these ends up being a rational number. Okay, anytime you have a square root of a number that's not a perfect square, that will be an irrational number. The square root of 10 is a decimal that goes on, is a decimal that goes on forever and ever and ever. So if I add that irrational number to a rational number, if I just add 11 to that, guess what? I still get a decimal that goes on forever and ever and ever. So that will still be irrational. But they want to know which one of these is rational. Okay, so it's not that one. All right, let's check this one. Let's do the parentheses first. Square root of 3 plus the square root of 5, I can't add those. That's 1 apple plus 1 orange. I can't add those. Okay, so in this case, I would just multiply this on my calculator. I would do 3 parentheses, square root of 3. Press. If your calculator's not like mine, guys, you got to get the cursor out from underneath there. So you got to press this little over button. Press over. Now I'm outside the house. Plus the square root of 5. Get outside the house. Close the parentheses. Okay, is that a decimal that goes on forever and ever and ever? Yep. So that's not rational. What about C? What is the square root of 9? That's 3. What's the square root of 4? What's the square root of 16? 4. 3 plus 4 is 7. Guess what? That's a whole number. That's a rational number. So the answer is C. The square root of 7 plus 2, the square root of any number that's not a perfect square is irrational. It goes on forever. So that will be an irrational number. Okay. Okay. There's 3 pages down. I'm going to have to leave here shortly, guys, to pick up my son and daughter because my wife is out of town. So let me see if I can get through a few more, and I'll stop. Let's see if I can get to 30, about halfway, and I'll stop, and I'll do part 2, maybe tonight or tomorrow. Okay, let A be non-zero rational number and B be an irrational number. Okay, all right. So, which of these expressions must be a rational number? Okay. So here's where we talked about this in class. If you add an irrational plus an irrational, if you add a number that has a decimal that goes on forever plus another number that has a decimal that goes on forever, guess what? That'll be a decimal that goes on forever. So irrational plus irrational is irrational. If you add a rational number plus an irrational number, that would be like 4 plus the square root of 7. Okay? If you add 4 to a decimal that goes on forever and ever, you're still going to get a decimal that goes on forever and ever. So that's also going to be irrational. The only way to get a rational number when you add is to add a rational number plus a rational number. That will be a rational number. Okay, so they're saying A is rational and B is irrational. B plus 0, that's still going to give me irrational. A plus A, rational plus rational, that does equal rational. Okay. A plus B, rational plus irrational is irrational. B plus B, irrational plus irrational is still irrational. Okay. All right, 28. A model of a house is shown. What is the perimeter in units of the model? Okay, remember, perimeter just means adding up the lengths of the fence. I'm going to add that guy plus that guy plus that guy. Okay, so I'm going to add all these lengths. That length plus that length plus this length plus that length plus that length. I'm just adding up all these outside lengths. Okay, I don't have numbers or expressions for all these lengths. Well, they're telling me this is congruent to that. So if that's 12x plus 3, guess what? That's 12x plus 3. This is an isosceles triangle. If that's 6x minus 4, guess what? That's 6x minus 4. So to find the perimeter, I just need to add all these guys up. Okay, so to do that, I'll come down here so I have room. Perimeter is going to be, I'm just going to add them all up. 6x minus 4 plus another 6x minus 4 plus a 12x plus 3 plus 14x plus 3, or excuse me, 13, plus another 12x plus 3. Okay, that's just combining like terms, apples and oranges. 6 oranges plus 6 apples plus 6 apples plus 12 apples plus 14 apples plus 12 apples is 50 apples. Negative 4 minus 4 plus 3 plus 13 plus 3 comes out to be plus 11. So the final expression for my perimeter is 50x plus 11. Okay, I think that's going to have to be it, guys. Didn't quite make it to 30. So I'm going to stop there for part 1 of our EOC review packet right at an hour. So yeah, this is going to be over 2 hours for both of these parts. So we will see you in part 2.